Let's talk about function, one-to-one property, and vertical line test. I know there is a lot of word, but it is very easy. A function is a special relationship where each x has a single y. So simply speaking, if an x value is assigned to a y value, the same x value cannot be assigned to another y values. Just like one-time use. So if you use the x once, that x cannot be used again. So let's say when x is equals to 5, y is equals to 6. So that means you cannot say when x is equals to 5, y equals to something else. All right, so x equals to 5, y is equals to 6. This is 1 point on the graph. You cannot say when x is equals to 5, y equals to something else. So let's say you insist to do so. You have x equals to 5, y equals to 6, and then the next point is x equals to 5, y is equals to 10. So this is not one-to-one anymore. So what I just said, let's read this again. Simply speaking, if an x value is assigned to a y value, the same x value cannot be assigned to any other y value. So you assign x equals to 5 to a 6, that means you cannot use x anymore. If you say when x is equals to 5, y is equals to 10, then this is not one-to-one. One x goes to one y. So if you have x equals to 5, y equals to 10, then this is 1-to-2. So let me just write down for you. So you have a point 5, 6, so x and y coordinate. So this is 1 point on the graph. If you say x is equals to 5, y is equals to 10, then this is not one-to-one anymore. X is 1-to-2. One x goes to two different y. The first one is 6, the second one is 10. So if you only have x 5 comma 6, then yes, x is 1-to-1. You use x one time only. But if you have 2 points, 5 comma 6, 5 comma 10, then this is 1-to-2. So the one-to-one property is violated. Then you don't have a function. So if a graph of a function is shown, sketch a vertical line to test if the function is a function or not a function. There are two cases. The first case is if the vertical line crosses exactly 1 point on the graph or the relation represents a function. So let me show you how to do this on the first graph. So you draw a vertical line, and then you are going to ask a lot of questions. Hey, can I draw a vertical line right here? And can I draw a vertical line right here? The answer is you have to draw a vertical line within the graph. So since the x goes from, do you see there is an arrow? So there is a left arrow and a right arrow. Can you draw a vertical line between these two arrows? So let's say right here. Or you can do it right here, or you can do it right here. It doesn't matter where you position the vertical line. So do you see that there is exactly one intersection, right? So there is one intersection. So that means this is a function. This graph represents a function. And then what about case 2? If the vertical line crosses more than 1 point, so let's say I draw a line right here, or I draw a line right here, how many intersections do you see? I see 1 intersection and 2 intersections. So this is more than 1 intersection. So that means this is not a function. It is just that simple. You sketch a vertical line. If you see exactly 1 intersection, then you have a function. Otherwise, you don't have a function. So let's do more practice. So how about the next graph? The next graph, you draw a line. I see exactly 1 intersection. Then I will just write there is 1 intersection. What is 1 intersection mean? 1 intersection means the one-to-one property is satisfied. Each x goes to a y. So if you use the x one time, that x value cannot be used again. So this is a function. The curve represents a function, not the vertical line. And then the next one, so this is a straight line. So we draw a vertical line. I see exactly 1 intersection. So this is 1 intersection. That means the one-to-one property is satisfied. You get 1 intersection only, then this is a function. The red line is a function, and the previous curve, the previous one, the red curve is a function. And then the next one, is this a function? So if you draw a line right here, of course you don't get anything, but what happens if I do it like this? if I draw a line like this, I see infinitely many intersections. So this one, many intersection. So that means the vertical line is not a function. How about the last one, a horizontal line? So simply sketch a vertical line. I get exactly one intersection point. So one intersection. That means the horizontal line is a function. It is just that simple. You sketch one vertical line. So shoot one vertical line across the graph. If you see exactly one intersection, that means the one-to-one property is satisfied. Then the curve or the straight line is a function. If you see more than one intersection, then the graph is not a function. Okay, so keep moving. So I have two more graphs right here. So this one, it doesn't matter whether you go like this, or this, there is exactly one intersection. So there, right here, there is exactly one intersection. Then that means the red line is a function. What about the last one? The last one, if you draw a line right here, there is exactly one intersection, right? If you draw a line right here, there is exactly one intersection right there, one intersection. However, if you draw a line right there, okay, actually I didn't make my line straight, so that is my mistake. So if you draw a line like this is many intersection. So this, you have many intersection. So that means this is not a function. The rule is this: as long as I can draw one vertical line and get more than one intersection, then the entire graph is not a function. That's the rule. As long as I can catch you one time, I sketch one vertical line and I see more than one intersection, then the entire graph is not a function. How about table values? So I don't have a graph this time, I have a table value. So when you have table value, check the x value first. If you see any duplicate x, pay attention. So this one, I have 1, 2, -6, 0, and 7. I don't see any duplicate x. So every x goes to a y value. So this is a function, right? So this one, okay, how do we say this? I will just say each x is assigned to a y value, and can I say no repetition? I don't want to say no repetition because that word is pretty confusing. So I will say none of the x is assigned more than one time. How about that? So none of the x is assigned more than one time. So the one-to-one property is checked, then this is a function. How about the second graph? So the second graph, I want to do a what if. So before I draw anything on the graph, I will just copy this graph first. Okay, so now I'm going to do the work. Do you see that there is a 3, 3, 3, and 3? So when you see a duplicate x value, pay attention to that. So 3 is assigned to 8, but in the next 2 points, you use the same x again, and 3 is assigned to -2 and pass the 4. Is this a function? The answer is no. So this is not a function because x equals to 3 is assigned to 3 different y values. Alright, how about this? So let me go ahead and paste this. So how about this? What if I make some changes? So how about I change all this to 888? Is this a function? The answer is yes, this is a function. 3 is assigned to 8, but you see duplicate 3, I understand that, but they are all assigned to an 8. So that means you have 3 identical points lying one on top of each other. So this is still a function. But if you change the problem again, so if you change the problem to let's say 20, is this still a function? The answer is no. So this is how I check it. 3 is assigned to 8, good. And then 3 is assigned to 8 again. That is okay, because if you graph this, you have 3 comma 8, and then you have another point on top of this 3 comma 8. So that is completely fine. But as long as you reach to the next point, you have 3 goes to 20. So this is bad, because we just break the one-to-one property. This is 1-to-2 now. 3 is assigned to 8, but you use 3 to assign to 20. So that is not 1-to-1 anymore. Then this is not a function, because 3 is assigned to 20. You use the 3 more than one time. All right. So how about dots on the graph? So this one, we go by the same rule. You draw a vertical line. So this one, you can draw a vertical line like this. So it doesn't matter where you place the vertical line, right? You get one intersection. So one intersection. So this is a function. How about the next one? So if you play with these 3 dots, you have one vertical line, right? But if you play with these 3 dots, how many intersections do you have? I didn't make them straight enough. So how many intersections do you see? So this is 3 intersection, because 2 is assigned to 6, 2 is assigned to 2, and 2 is assigned to -1. So if you have a table XY, you have 2, 2, and 2. So 2 is assigned to 6, 2 is assigned to 2, 2 is assigned to -1. So this is not 1-to-1 anymore, because you use the x value 2 3 times. So this is 1-to-3, then this is not a function. All right, that's how easy it is. If you think my instruction is clear and helpful, give me a like, share the video for me. If you're on your way out, click the subscribe button. I will see you all in the next lesson. Signing out.